was showing same intensity of color. There was no difference in color development from S1 to S5. So five series of standards with different uh, concentrations was giving same color. Okay, that should be a gradual increase in intensity of the color because of the concentration and activity of the transaminase. However, that was not visible. What did we see? We saw the same intensity. That is the problem. Okay. So the second part of the problem was the test and control tubes that we had incubated earlier were showing no colors at all. Okay. It was colorless, just like blank solution. Despite adding all the solutions and following the protocol properly, you are not observing any color development in test and control tubes. At the same time, the intensity of the color development in all the standards were same. Okay, so that was our problem. So when did you identify this problem? Completed. All last step was remaining. Taking readings was remaining. That was the time you identified the practical. That is during performance of the practical, not before that, not after that. During performance of the practical, when you have completed incubation period, you observe that there is no proper color development in test and control tubes, no color development at all. And series of standards were showing same intensity. There was no darker or lighter color. It was same. Okay. So this is our problem and this is our timeline. So what is the problem? No color development and no variation in intensity in standards. When did you identify? When you are doing the practical, when you are supposed to take the readings in the photometer, you came across this problem and you identified it. Okay. So that is our basis to start this troubleshooting. That is all information we have. Anyways, so next let us see what we have to do. We have to focus on the parameters or the factors that are involved in this experiment. Okay. Again, we will see which are controllable and which are non-controllable variables as we have discussed. But here, let us have an overview of all the factors that are included. That means any variation of these factors can have an effect on our analysis, and one of these factors has had an effect on our analysis. Okay. Number one will be our reagent. Preparation and storage of these reagents plays a very important role because these reagents are prepared one day prior to the experiment. Okay, so on the previous day we prepare it and we store it as per the protocol, all the procedures that are given to us. So can it have an effect on our testing? Let us see. So sub question number one that you are supposed to ask when you are trying to identify the root cause of reagent will be who prepared it. Okay, the people who prepared it and people who have performed the experiment, are they same? Okay, so here in this case, these were prepared by lab technicians. Okay, separate set of people have prepared it and the students have performed the test. So there can be a discrepancy between these factors. So our root cause can hide here also. Second question you asked was when it was prepared. Okay, certain buffers, as you are aware, have very short stability. You need to keep on preparing it as per the requirement. So in this case, these were prepared on the previous day. It was not long back. It was only done in the previous afternoon. Okay. How did you store it? Will be the third question. As per the protocol, what does the protocol say? Certain reagent needs to be stored in refrigerated conditions. Certain reagent needs to be stored in room temperature. Certain reagents should be stored in brown color bottles. Some certain reagents can be stored in transparent bottles. So as per the protocol, as per the guidelines given in the protocol, the storage was performed. So this was the information we obtained from the people who have done it. Okay. So when you speak with the people who have done it, this is what we have come across. This is the data we have regarding the factors in reagents and preparation and storage. Can there be any variation in these factors? Okay, what will be the possible variation? Will be the next question you are supposed to ask. Okay, during preparation there can be improper mixing. Okay, so mixing might not have been proper, so the contents of the reagents were not dissolved, it remained as it is. So that's why it changed certain aspects of the quality of reagents and we did not get the desired result. Was it stored properly? Was the protocol correct in store? What was the source of the protocol also is very important. Was it somebody told them to do it or did they check through the manual? Okay, so that will also play a very important role. Here in this case, it was done as per the manual. Okay, and finally, this is a very important thing that we have to focus quality check. Okay, you actually check the quality. Whatever you have prepared, the reagent that has been prepared, is it as per the standards? Okay, will it develop a color? Will it be useful? So that part of quality check, was it performed or not? Okay, it also plays a very important role. So in this factor, reagents is a factor. You are supposed to ask these many questions and you need to come up an answer. You have to get an answer to this, and then we analyze all these answers. So the second factor is it's also very important because all of these reagents that we prepare it in glassware. Okay, so we prepare and store it in different forms of glassware. So cleaning is very important. Okay, so cleaning, if there is no proper cleaning, that can lead to cross contamination. Any contaminant that remain from the last experiment can interfere uh, with the reaction and give us wrong results. Okay, so what are the questions you are supposed to answer here? Number one, who cleaned it? Okay, who prepared the glassware? Who cleaned it and kept it ready? Again, it were lab technicians. Okay, then what possible variations can happen in this factor? Number one, as I already told you, impurities within the tubes leading to cross contamination. If impurities remain, that means there is no proper cleaning. This deposits which are already there in the tube can interfere with the test and give us a wrong result. Okay, so that's a very small question that you are supposed to answer. The third one will be pipetting. Okay, so when you are pipetting, there's a possibility that contamination of pipettes can happen. How does it happen? When there's a large area of people performing the analysis, one person can change the position of the pipette. Okay, so let's say you are using a 10 ml pipette for region X, and based on the availability, somebody will take it from there and use it for reagent Y. Okay, so what has happened here? The liquid that was already, the reagent that were already present in the pipette is going to contaminate reagent Y. Okay, so this is what we mean by contamination of pipettes. Who pipetted it? The students or the uh, learners pipetted the reagent. So what can happen then? What are the possible variations? Number one, mix up of pipette leading to cross contamination. So did it happen? The next factor is mixing and incubation. Okay, so how mixing and incubation can affect our test? Few questions you have to ask. How was the mixing done? Okay, was it manual or was it mechanized? Okay, so we used a vortex mixer to mix all the contents. Incubation time and temperature 60 to 60 minutes at 37 degrees Celsius for the initial test and control tube, and 20 minutes at room temperature for set of reagents. Okay, for development of color, we had done this incubation. Possible variations. Was the mixing proper? As it was mechanized, we expect proper mixing. Incubation, was it adequate? Was the temperature proper or the time, any issues with that? You have noted the time in your observation book. So I don't feel the incubation was not enough. Okay. So the next factor will be the reading part of the reagent. Okay, measuring the absorbance. What can happen here? We are using a photometer. So what are the possible variations? Number one, quality of photometer. Is the quality okay? Okay, is it working properly or not? And second will be the maintenance status. Was it maintained recently or not? Okay, we'll see each question. So these many questions you are supposed to ask. Then there are some non-avoidable factors that are involved, and very important one is the human factor. Okay, so all this information that we collect, we are supposed to collect, are based on the inputs from lab technicians. What lab technicians say, based on that we can do the analysis. Only that is possible. We cannot uh, get information from somewhere else and try to do it. It's only on the basis of the inputs, whatever the lab technician says. So we are taking so much information on their word. We have to trust their word. So it is very important that we do every answer. Okay, we come up with answers to these questions very objectively, not subjectively. Okay, so that brings us to the analysis part. So this part is very interesting and little bit confusing also at the same time. So we'll take some time, okay, 7 to 8 minutes to clear this out. So we are trying to find answers for each factors, each query, and try to see if we have to include or exclude as a possible cause for the problem that we have faced. Okay, so based on what we have discussed earlier, we have reagent preparation and storage as our first factor, first query. The possible variations can happen in improper mixing, improper storage, and quality check. Okay, so improper mixing, should we include this during troubleshooting or should we exclude this? So we exclude this. Okay, why? Because when they were preparing based on their input, there was no residue that was visible. If the mixing is not proper, that means some amount of the solid chemical will remain within the beaker during preparation. So it was not visible, so there cannot be. We are excluding it, so we don't have any solutions for that. Improper storage, again we are excluding because the storage was done as per the protocol, as per the recommended guidelines. Now, this point is very important. Quality check. Did they check the quality of reagent before the performance? So in this, we are including it. Okay. Why? We found out that variation in the pH of the substrate buffer, both alanine and aspartate buffers, were changed than the required pH. Now, due to acidic pH, what we saw that the pH was highly acidic in both. The activity of transaminase remained uniform across the series of standards. So there was no actually changes in transaminase activity. It remained same because of the change in pH, variation in pH than the recommended ones. Yeah. And so how to solve this issue then? Check the pH every time. Okay, before the start of the test, every time you have to check the pH. If the pH is not proper, bring the pH or adjust the pH to the recommended guidelines, and then you do the testing. Okay, so factor number 2 was glassware. The query was glassware. Cleaning, we are excluding it. Okay, the reason I've given in A, because proper cleaning is done. Nobody during the performance of the test raised any issues with the quality of tube. Okay, it was clear. So let's go into pipetting. Was the cross contamination done? We are excluding it. Okay, is it possible? Okay, is it possible? The first question, yes, it is possible, as the pipettes were not labeled. In case there was change in position of this pipette, we could not have identified. Okay, but we can exclude this as our reason for developing a reason for the problem, because every tube in the standard has shown same color. Okay, if there was some cross contamination, at least one set, the first set who performed, should get a proper result. But across every one set of reagents we have seen, set of tubes we have seen, the color has not changed. It is same. Okay, and every control and test tube, it does not develop any color. So for this reason, we exclude that cross contamination as the pipette as the reason for our problem. However, it can lead to some problems when we do it again. So it's very important to correct this problem. So solution will be label the pipettes to make sure that there is no cross contamination. Okay. So we go into the next factors. Mixing and incubation. Mixing we exclude because it was mechanized. Incubation we exclude because temperature of water bath was constantly monitor. We kept on checking if the temperature was 37 degrees or not. Photometry, again, quality of the photometer we exclude because test before and after the experiment has shown readings. Okay, so there is no issues with that. Maintenance status, again, we are excluding because we do periodic maintenance of the photometer. So this is the analysis of all the information that we obtained during troubleshooting. So we have made across, we have included, if you see the factors that we have included as the possible cause of our problem is quality check. Okay, so we feel that quality check was the reason why we did not get the, the variation in intensity of the color that was supposed to be developed. Okay, so the last part is final report. Whenever you're doing a root cause analysis or troubleshooting, you have to note everything down and present it as a report. Okay, so what was the final report then? What was the problem? First of all, let us identify what problems did we identify. We identified that a series of standards were showing same intensity of color, no matter which dilution or which set of concentrations we were using, and there was no color development in control and test tubes. Now, when we did the root cause analysis, we identified the cause for this problem. The cause was failure to check the quality of reagents prior to the performance of the test. In case the quality check was performed, we could have led to the avoiding of this problem. So that is the actual cause of the problem. Failure to check the quality of reagents prior to the performance of the test. What is the root cause analysis? What is the exact cause for this? So variation in pH of the substrate buffer. Okay, as the pH was acidic, the activity of transaminase remained uniform. Okay, it did not change; it remained same across the series of standards. And finally, corrective action. How to avoid this problem in future? Check the pH every time before starting the test.